All right, parents, by now you may have seen this paper. This was our review sheet from today. Just gonna walk you through some of these problems. First question says there are 11 dots here splitting this line. Determine the fraction and label them. Part of the point of this is that there are 11 dots, so some of the kids automatically say that they're using 11ths as their fraction. But it's not about the dots, it's about the pieces that it's broken into. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 11 dots break this line into 10 pieces, which means that my fractions are tenths. So I would label it 0 tenths, 1 tenth, 2 tenths, and so on across each dot. And that's all you have to do on this particular problem is just label the fractions. Okay, I'm not gonna label all of them, I'll stop there. Then the next one says, what is the fraction in the middle? In the middle is this fraction right here. So if they have labeled them correctly, if they have figured out that it's tenths and labeled them correctly, they should be able to figure out that the one in the middle is 5 tenths. Now it says create 2 equivalent fractions for the fraction in B. So you want 2 equivalent fractions. What the kids have been taught is that if you multiply the same number by the top and the bottom, you'll get an equivalent fraction. For example, in this case, 5 times 2 is 10. And since I did times 2, I'm going to do times 2 down here. 10 times 2 is 20. I could also do times 3. 5 times 3 is 15. 10 times 3 is 30. Or I could do, sorry, we had an announcement. We've also talked about the fact that when you multiply something by 10, you're basically just adding a 0. So I could do 10 times 5, and that would be 50. 10 times 10 would be 100, and any one of these would be equivalent fractions for 5 tenths. Okay, the next one says, these loaves of bread need to be split differently. The first one needs to be split into fourths, and the next one split into sixths. We've told the kids, I've talked to the kids again and again and again about the fact that it's important that your fractions be split equally. So you always start by splitting down the middle. So for the fourths, I'm going to split it down the middle. Then I'm going to split each half into halves. That's about as close to 4 equally sized pieces as I can get. Some of the kids, let me draw another one for you. Some of the kids will do this. They'll just start putting lines right here. And then they'll go, oh, how many do I have? 1, 2, 3, 4, 5. And they'll say, okay, this is fifths. But I keep telling them you can't accurately gauge equivalent fractions when you've got a fraction like this that's so much smaller than this one. They have to be equally sized in order for you to be able to see equivalent fractions. So in this case, this one is broken into quarters, and then I'm going to bring that middle point right down. This one has to be split into thirds, so we'll do it about like that. And this one has to be split into thirds, so we'll do it about like that. That one's a little bit smaller, sorry, but that's close to the 6. So the first part is just splitting these, and then it says, if Sam eats 2/4 of the first loaf and Gavin eats 2/6 of the second, who ate less bread? So what I told the kids to do today was to shade in the 2/4 and shade in the 2/6, and then just see which one is less. Then you can, if you've set your fractions up correctly, then you should be able to visually see that the 2/6 is less. So the answer would be Gavin. Gavin ate less. All right, this next question says, Max told his friends that 2/3 is the same as 4/6. Do you agree? Using pictures, numbers, and words, prove why you agree or disagree. Okay, so the important part there is that there's 3 things they have to do. They have to use pictures, numbers, and words. We've gone over this with every practice sheet that we've done. They have to do it all 3 ways. So the best way to do this is to first draw your model. Sorry, I'm trying to do this while I'm filming, so it's probably not going to be pretty. But there's one model, and I tell them to put them directly above and below each other because it's the easiest way to see it visually. Then in this case, it's easier to split the 6th up first because you start with that middle piece. So there's my 6th, and then 2 6 is equal to 1/3, so I can just extend that line up, and 2 6 is equal to 1/3, so I can extend that line up, and there's my thirds. Now to indicate 2/3, I'm just gonna shade this in and shade this in, and then I'm gonna shade in 4 6. It doesn't have to be beautiful, which is good because it's not. This is 1/3, 2/3. This is 1 6, 2 6, 3 6, and 4 6. Okay, so now I've got pictures and numbers, and I can say that I agree because they take up the same space. I'm just gonna put because same space right now. But again, if they've set up their fractions correctly, then you can see how 2/3 is visually equal to 4 6. So that's how you would do that one. 3 equivalent fractions for 3/4. Again, 2 times 3 would be 6, 2 times 4 would be 8, 3 times 3 would be 9, 3 times 4 would be 12, 4 times 3 would be 12, 4 times 4 would be 16. There's 3 equivalent fractions. Okay, this last one is the most confusing, and I've gone through it really slowly with the kids in a couple of different ways on the 2 review sheets. You've got my pretend piece of wood right here, and then some of the measuring thing right here. It says a piece of wood needs to be split into pieces that are 1/3 of a foot. So at first you're doing 1/3 of a foot. So when I split that up, each foot is going to have 3 pieces. So there's each foot now has thirds, and when I label them, this would be 1/3, 2/3, and it says right here, it says rename the whole numbers. Rename the whole numbers just means instead of 1, you're gonna have 3/3, which is equal to 1. 4/3, 5/3, 6/3. Again, 6/3 is equal to 2. So that's what it means by renaming the whole numbers, is just naming them by the fraction. Okay, so at this point we're talking about thirds because we're talking about thirds of a foot, and I would label it all the way across to here, which this one would be 12/3. Okay, so this one there, I've done this question because I've labeled them, I've partitioned them and labeled them. Then it says, when cutting the pieces of wood, 3 of them were broken and unusable. What fraction of the wood is left? Okay, for the second half of this problem, you switch though. Now we're not talking about a fraction of a foot anymore. Now we're talking about a fraction of the whole piece of wood. So the wood was actually split into 12 pieces. Okay, so my fraction is gonna be 12ths. 3 of them broke, which means 9 of them are left whole. So the answer here is 9/12. So this was thirds because we were talking about thirds of a foot, but now we're talking about the fractions of the whole piece of wood, which was broken into 12 pieces. 3 of them broke, which left 9. All right, I hope that helps. I hope you guys understand where we're going with this. These questions are patterned after questions that are on the test. So if your kids can figure these out, then they're good for the test.